Hello everyone and welcome to another video. In this video we are going to be looking at how to find the maximum and minimum from any of the forms of a quadratic. So in order to do that, let's just run back through our forms of the quadratic, and this first one should make a lot of sense to you now. It's called factored form. Why is it called factored? Because it's fully factored. The second one, called standard form. And the last one called vertex form. And let's just run through what each of these tells you about the parabola. A in factored form tells you the shape, whether it's stretched or compressed, and the direction of opening. R and S tell you the x-intercepts. Now when we go down into standard form, the A tells you the same thing. In fact, in vertex form as well, all the A's tell you the same information. The C value here is going to tell us the y-intercept, and H and K together in vertex form will tell us the vertex for that parabola. Now what do you need to know in order to know what the maximum or minimum is for a parabola? So let's just think of a ball flying through the air. It's going to do something like that. And that's going to be the highest it ever gets. So that'll happen at H along the x-axis, and it'll go to a maximum height of K, giving you a vertex of HK. So you have the x-intercepts here and here. And if you only knew the x-intercepts, you wouldn't even know whether it opened up or down, whether it went way up here. So really you need to nail down where that vertex is in order to know what the maximum and the minimum is. Certainly the y-intercept's not enough information to give you. You don't even know whether it opens this way or this way. Okay, so this is the form you need in order to know the exact value of the max or the min. Now to know whether you're talking about a maximum or a minimum, you just need to know whether it opens up or down. So if A is greater than 0, remember from what we did before, that tells you that it opens up, which means it reaches a minimum value. If A is less than 0, then it opens down and it goes to a highest point or a maximum value. So if we can just get everything into vertex form, then we just read K off of the equation, and that tells us what the maximum or the minimum height is. So this becomes our motivation. We need to be able to switch between the forms to get to that vertex form. Now we already talked about this a little bit. In order to get from standard form to factored form, all you really need to do is just need to factor. So if you can factor, you're going to be able to get from standard to factored form, assuming that it's factorable. It's possible that it's not. If it's not factorable, then you're not going to be able to put it in factored form. Now going from factored form back to standard form, which we're not going to have to do in this case, if we did have to do that though, it's as simple as expanding and simplifying. Now if you wanted to go from factored form to vertex form, well, we had a way of doing that already. So what we were able to do was read the x-intercepts off of R and S, find the midpoint between those x-intercepts, so in this case it would be -1. Take that -1, plug it in for x in factored form, solve for the y value of the vertex, and if you already know A, because A is the same for every form, and we use the x value of the vertex for H, and we use the y value of the vertex for K, then we're able to put this into vertex form. Now, that's fine, except for it's a lot of work. You have to go from standard form to factored form. So you got to know a lot about factoring. And you have to go from factored form to getting the x-intercepts, to getting the x value of the vertex, to getting the y value of the vertex, and then finally plugging it into vertex form. And that will give you vertex form. That's fine, as long as the equation is factorable. Some equations aren't factorable, but all parabolas have vertices. They all have a vertex. So you don't have to have an x-intercept to have a vertex. So if you try to think about the graph that looks like this, you can see that this will not give you anything in factored form. You won't be able to get it in factored form because there are no x-intercepts, but it certainly has a vertex. So this method will break down if you try to do it for something that looks like that. So what we have right now is a method that works some of the time, not always, and is long and requires you to go to an intermediary step of going to factored form. So let's not do that. Let's just go right to vertex form from standard form. So take a look at standard form and take a look at vertex form. And so what I want to do for now is I want to take vertex form and make it look a little bit more like standard form. Okay, so bear with me here. This is one of the most confusing things that you're going to see in grade 10. So I want to make sure that you have some understanding of what's happening here. So I'm just going to take this and expand and simplify it. So I'm going to use the shortcut trick, okay, in order to do that. If you need to write it out yourself, you should, in order to see how this is working. And so now it looks a lot more like the original standard form. So if I can take my standard form and make it look like this, then it's quite straightforward to go back to there. Okay, so the first step that I notice that I need to do, and we'll do this with an example because I think that it helps in order to see this with numbers first, is that I notice that I have an a factored out. Well, I don't over here. So that's the first thing I'm going to do, is I'm going to factor out my a value. So in this case, a is minus 2. And what do we get left over? Well, we end up with x squared minus 10x. Now, I could keep going and try to factor the minus 2 out of minus 7. That's going to be messy for one. The numbers don't work out well. The other thing is I don't care about this number out here because I have a number out there. So I'm going to leave it hanging out there. Okay, so I'm going to close that bracket. And I'm going to have that minus 7 still there. Now this looks fine, except for I don't have this h value here hanging off the end. I need to tack on a number to make it look like this. And I have to make a good choice here because it has to be the number that matches with this middle term. So what I'm going to do is I'm just going to write out both this perfect square trinomial. Okay, so x squared minus 2hx plus h squared, and I'm going to write out what we have right now, which is just x squared minus 10x. And I'm going to take careful consideration and kind of notice that what I have here is this minus 2h has to be the same as minus 10. Okay, and all I'm trying to do is figure out what number I need to tack on here. Okay, so I've learned that minus 2h has to equal minus 10. So h is equal to 5. And so now that tells me my tack-on number. The tack-on number is h squared. So h squared is equal to 25. And that's going to be the number that will make this a perfect square trinomial when you add on an extra number. Okay? We add that number on, it'll make it a perfect square trinomial. Which is our goal, right? We want this to be a perfect square trinomial so that we can go from here back to there. Like I said, this is super confusing at first, but it gets a little better. So my change I've made, I'll highlight this in red, is that I'm going to add on 25. Okay. Now you can't do that. That's not okay. Okay. You can't just add numbers onto parts of an equation. You change the values that you would get when you plug in x. So if you plugged in 1 for x, you're going to get a different number for y now. So we've changed the equation. So I'm allowed to do that as long as I take away 25. Because what I've effectively done is done nothing then. I've added nothing on. I've just changed the way it looks. But I haven't changed anything about the values because I'm just adding on a net value of 0 here. Okay, but what I've done is I've created a perfect square trinomial right there. These first 3 terms make a perfect square trinomial. And if you remember your perfect square trinomial factoring, then we can write that as x minus 5, all squared. Now be careful, really common mistake is that people forget that we had to subtract off this 25. So we only included these 3 when we factored into there. So this needs to come down as well. Okay, we just close our bracket now. This big bracket here, we're closing over here. And we're going to subtract 7 on the end. That 7's still there. Oh, let's try to finish this up now. Now, this is really close to y equals a x minus h all squared plus k. It's pretty close, except for we have these two numbers out here. We just want one number. So we have to distribute the 2 back into the bracket. Be careful when you do this. All I'm going to do is write 2 times this bracket, because I want that bracket to stay there. I don't want to re-expand and simplify. That's something sometimes people do. So I don't want to do that. I'm going to get plus 50 when I multiply the second term, and then subtract 7. So y then equals minus 2 x minus 5 all squared. Put these together, and you get plus 43. So now the vertex for this is equal to minus 5. Remember, it's the opposite, or sorry, plus 5. The opposite sign that you see there, and 43. Okay. So in order to do this, the first thing you want to do is expand and simplify. And since we've already done this before, I'm going to do this really fast. So minus 4, I'm going to use the shortcut, x squared minus 6x plus 9 plus 5. Bring the minus 4 into the bracket. You're going to get minus 4 x squared plus 24 x minus 36 plus 5. Okay, so altogether minus 4x squared plus 24x minus 31. Okay, and then we're going to try to go back into this form that we started with and check and see if we can complete the square if we're able to do that. So here's the form that we're starting with. First thing, I'm just going to write down vertex form as a goal so that I don't forget what I'm trying to accomplish, and that I can use the form in order to guide me. So first thing, factor out that a, but just from the first two terms. X squared minus 6x minus 31. Okay, now what we're going to do is effectively what we were doing before is we were comparing this against the middle term when we write out the expansion of this perfect square. And it was like minus 2h. Remember that? Now, we ended up having to divide both sides by 2. So that's what I'm going to do. I'm just going to divide this by 2 and then square it. Okay, that's always going to be the case. Okay, so I'm going to take minus 6, divide it by 2, and square it. So that's going to be minus 3 squared, which is 9. And that's my tack-on number. I like to think of it as. That's the tack-on number. And it's going to go right over here. Okay, so that's what we're going to do there. So minus 4 x squared minus 6x plus 9. But, and again, I'm going to put this red because it's so important and it's the thing that people forget to do. You have to take that 9 away because you have to do effectively nothing. This part here is a perfect square trinomial now. So you're going to be left with minus 4. Use those big square brackets. This is going to be x minus 3 all squared. And don't forget about that minus 9. That's not included in the perfect square trinomial. Okay, minus 31. Now we just bring that minus 4 back in the bracket. We get minus 4 x minus 3 all squared plus 36 minus 31. And just add like terms. X minus 3 squared plus 5. And that, we completed the square to get it back into vertex form. Okay, so there's a lot of other little parts about this. For example, a lot of questions will now ask you what the max or min is, and those questions just depend on you understanding what vertex form tells you. And so this is the new thing. So hopefully you'll be able to tackle a lot of the problems now.